Greetings and welcome to Train Signal. You're watching Introducing Enterprise Voice with Microsoft Link Server 2013. In this video, we're going to start off with an overview of Enterprise Voice, which is Microsoft's voice over IP solution. When you're using a product for your voice over IP, you want to make sure that it's highly available and that it's resilient. You want to have a dial tone. You want to be able to make and receive phone calls. In this video, we'll look at the high availability and resiliency features of the product. We're also going to look at your PSTN connectivity choices and the role of your mediation server in your link topology. At the end of the video, we'll provide a demonstration on defining your mediation server and your gateways inside of your topology builder. What exactly is Enterprise Voice? Well, it's Microsoft's voice over IP solution with Link. Your Microsoft Link server can function as your PBX. Microsoft Link also has the ability to integrate or interoperate with existing PBX infrastructures. So Link can either enhance or it can replace traditional PBX systems. When you enable a user for Microsoft Link, the users have the ability to make peer-to-peer calls within the organization, even if you're not using the feature called Enterprise Voice. So if I have a couple of clients in my organization, they can use Microsoft's real-time audio to communicate using their Link clients. If a user is Enterprise Voice enabled, they can make calls beyond the organization. They can dial traditional phone numbers outside of the company. Microsoft Link supports your traditional calling features. As you're on a call, you can answer additional incoming calls, and you can initiate outgoing calls, putting your current call on hold. We have the ability to transfer calls from one user to another, and a feature which I really like is the ability to transfer calls to a different device. So at the end of the day, when you need to get out of the office, you can transfer a call over to your mobile phone. Microsoft's Enterprise Voice is a voice over IP solution with benefits. It has a lot of additional rich features. If I'm on a call using my Microsoft Link client, I can easily add text, video, or application or desktop sharing to the call. When you configure Enterprise Voice, we typically integrate it with a Microsoft Exchange server on the back end for the unified messaging. So when a call comes into the organization, if the call goes unanswered, it can get routed over to the unified messaging server, and the unified messaging server can play an audio prompt, record a voicemail, and deliver it to your mailbox. The server can notify your Link clients when they have missed calls or if they have messages awaiting. You can listen to your messages from inside of your Link client, but you can also listen to them using your mail client like Outlook. And if you have at least Exchange Server 2010, Microsoft also has voice-to-text preview. When a voicemail gets recorded and put into your mailbox, Microsoft Exchange translates the voice to text so you can read it. Microsoft's Enterprise Voice supports several advanced features, such as delegation, team calling, and response groups. Delegation enables an Enterprise Voice-enabled user the ability to delegate call handling to assistants. So a delegate can perform tasks on your behalf, such as screening calls, placing calls, or possibly scheduling conferences. Another feature called team calling enables users to have incoming calls ringing simultaneously on all the phones of the members of a defined team. We also have a feature called response groups, which is the automated call distribution. It allows an administrator to define workflows to intelligently route calls to queues getting serviced by groups of agents. We'll be using this feature to route the calls to our help desk at Carverock Fitness. One of the big concerns that we've had while working on the design for Enterprise Voice at Carverock Fitness is bandwidth usage. Link Server 2013 has built-in support for bandwidth control with call admission control. Call admission control allows us to define network bandwidth policy profiles, which define how much bandwidth can be used for real-time audio and/or real-time video, on both a per session and on an aggregate basis. So as a user tries to place a call across a WAN link, for example, when a user in Mesa calls over to Scottsdale, the user that's being called will contact the network policy server to see if it's okay to accept the call or not. And if it's not okay to accept the call because bandwidth is being overutilized, the call can either be rerouted, like for example through the PSTN lines, or the call can be rejected. With Microsoft's Enterprise Voice, we can also use the Location Information Services, better known as E911. When a client powers up and they register in the Link environment, based upon where the client is on the network, whether you're connected to a certain switch or switch port, maybe to a wireless access point, or maybe you're on a certain subnet. This information can be mapped down to civic addresses inside of the Location Information Server database. When you register with the list server, the client will provide it with known information. The list server will check in its database, and if it has a known address for the client, it passes that address over to the client in an XML-based format. If the client dials 911, the location information gets passed along with the call. So the emergency responders have a known address for you, and they can route the call to a local public safety answering point. So it doesn't matter that you might be out in Mesa, but the call is getting routed through Scottsdale or Phoenix. With the location information, a user in Mesa should have emergency calls routed to a local public safety answering point near Mesa. Microsoft Link provides a lot of support for interoperating with existing infrastructures. At Carve Rock Fitness, we currently have a legacy PBX. When we get the enterprise voice deployed, we want to move the users over to enterprise voice, but we're not going to do this all at once. Link supports direct interconnectivity with SIP with IP-based PBXs. Because we have a legacy PBX, we're going to have to purchase a qualified gateway so Link can communicate with that PBX. We're looking at coexisting for a couple of months until we get all the users over to Microsoft Link, and then we're going to decommission our legacy PBX. Microsoft Link Server supports G711 and G722 as audio codecs. They've also added G723.1 with Link 2013. While designing our enterprise voice, another hot topic is media bypass. Media bypass is a feature that Microsoft came out with back with Link 2010, and it allows an office that has a gateway but no mediation server to allow the audio portion, the media portion of the call, to go directly to a gateway and bypass your mediation server. When you place a call, the SIP traffic will go through the mediation server, but the audio portion of the call can go right over to the gateway. So in the case of a remote office that doesn't have a mediation server locally, it prevents the call from having to go across the WAN link and then possibly back across the WAN link again to get over to the gateway. So it cuts down on network utilization, latency, and possibly drop packets. By using media bypass, it also means that much more audio doesn't have to go through the mediation server, which in some cases may be an argument for co-locating the mediation server on your front-end servers. Let's take a look at high availability and resiliency with Link Server 2013. In order to provide high availability with Microsoft Link Server 2013, our main high availability scheme is to use what's called pooling, where you set up your servers together in a pool. The Enterprise Edition of Microsoft Link allows you to set up multiple servers together in a pool. So if one of your servers in the pool goes down, that's okay because we still have other servers there to handle the load and to provide service to your clients. When we're defining our topology and designing the infrastructure, we can define pools of servers for front-end servers, edge servers, mediation servers, and even directors. With Link Server 2010, we had the ability to go into our topology builder, and when you went to the properties for your pool, you could define what was called a backup registrar pool. So if a client tried to register up against its pool, where the client was homed, if that pool was not available, your client could try to register up against the backup registrar pool. If your client is able to register up against the backup registrar pool, they would run in survivability mode. The client would have a lot of the basic functionality for enterprise voice. They can make and receive phone calls, they can gain access to their voicemail, they can call people within the organization or people outside the organization. But if your pool was not available, your application services running on your pool were not available to you. For example, automated call distribution, or your conferences. If you had scheduled conferences, they weren't going to be able to run because your pool was down. With Link Server 2013, Microsoft has expanded on the concept of backup registrars. We now have the ability to define pools and peers. So in our design, we're going to have a couple of sites, one in Phoenix and one in Scottsdale. And we're also going to have a pool in each of those locations. We can set up those pools in a pool pairing design. If a client is not able to log in and register with their pool because it's down, we can fail the clients over to the other pool. Now, this is very similar to the concept of using backup registrars, but what Microsoft has done, they're now replicating a lot of the user home data. A lot of the information inside of your RTC database now gets replicated by a new backup service in Link Server 2013. When you set up your pools in a paired design, this automatically gets deployed. So now if I'm a user that fails over to another pool, my backup pool that's been paired, I should be able to still gain access to my conferences. When you're designing your pools in paired sets, you want to make sure that you take into consideration capacity planning. Because if another pool goes down, I have to be able to support that many users coming over from the other pool, even if it's only for a short period of time. When you define your pool pairing inside of the topology builder, the paired pools will function as backup registrars to each other. So if I have my pool in Scottsdale paired up with my pool in Phoenix, they're going to function as backup registrars to each other. So if a client goes to register in Phoenix and they're not able to because their pool is down, they can register over in Scottsdale. And if in Scottsdale my clients can't register because their pool is down, they can register with their backup registrar over in the other location. With Link Server 2013, the backup registrar relationship between your front-end pools is 1-to-1. So when you set up your pools in a paired set, they are going to be the backup registrars to each other. When you define survivable branch appliances inside of your topology, we can also define backup registrars for your SBA. When you're defining your survivable branch appliances inside of your topology, you want to keep in mind that Microsoft does not extend disaster recovery support to users homed on survivable branch appliances. If you have a front-end pool that is functioning as the backup to a survivable branch appliance and it goes down, users signed into the SBA fall into resiliency mode, even after the users homed on the front-end pool are failed over to the backup front-end pool. So the users registered on the SBA will have limited functionality. In order to provide voice resiliency for clients out at remote offices, we can deploy survivable branch appliances or survivable branch servers. At Carve Fitness, our telephony is centralized over in Phoenix and Scottsdale, but we have a lot of branch offices that connect across WAN links, and all of the links are not high speed and highly resilient. They go down every once in a while. To provide the users out at the remote office the ability to make and receive phone calls, we can deploy an SBA for the smaller offices. A survivable branch appliance is designed to support up to 1,000 users. When you purchase an SBA, it's a blade that comes from a vendor pre-installed with the server operating system. It has the Link 2013 registrar, the Mediation server role, and it also has an integrated gateway built right in. So even if the link over to our corporate site goes down, as long as my SBA has local connectivity through a provider, we can still make and receive phone calls. When you're looking for appliances, you want to take a look at the Unified Communications Open Interoperability Program website for Link. You'll find supported devices from vendors such as HP, NET, AudioCodes, Ferrari, Dialogic, and Cisco. Keep in mind that the list does get updated. For larger corporate branch sites, Microsoft also supports survivable branch servers. A survivable branch server is very similar to a survivable branch appliance, but you don't purchase this from a vendor, you have to set up the server yourself. A survivable branch server is designed to support between 1,000 to 5,000 users. When you install a survivable branch server, the server will have the registrar role for Link and the mediation server role. It does not have the integrated gateway like an SBA. If you're at a location that has a survivable branch server, the SBS will provide the ability to make and receive phone calls, even when the WAN links over to our centralized telephony in Phoenix and Scottsdale goes down. When you're designing an enterprise-grade voice-over IP solution, you want to make sure that your clients can make and receive phone calls without any underlying knowledge of the technologies. To provide connectivity to the public switch telephone network, Link supports both PSTN gateways and SIP trunks. We can also communicate directly with an IP-based PBX using direct SIP. For legacy PBXs, we can communicate with them also coming in through a qualified gateway. At Carve Fitness, we currently have a legacy private branch exchange. Link can communicate with a legacy PBX through a qualified gateway. Microsoft Link can also communicate with IP-based PBXs directly, and for IP PBXs that lack certain features, we can also use a qualified gateway in between the mediation server and the PBX. For example, if your IP PBX doesn't support media bypass. A traditional method of connecting into a PSTN connection is through a PSTN gateway. These are third-party devices that translate signaling and media between your enterprise voice infrastructure and your public switch telephone network. When a call comes through our gateway, the gateway communicates over with our link mediation server, which can either be co-located on the front-end servers or can be separated out as a dedicated role. As an alternative to using a PSTN gateway, we can also use SIP trunks. A SIP trunk is a connection from your mediation server over to the session border controller of your provider. A SIP trunk connection can be across a dedicated line, it can be across a VPN on the internet, and it can also be across a non-secure channel. Not that you want to do that, but it is possible. In order to understand how enterprise voice works, we have to understand the role of the Link 2013 mediation server role. In order to deploy enterprise voice, you have to deploy a mediation server in your environment. A mediation server is the role that handles the intercommunication with your gateway, your PBX, or your session border controllers. The mediation server is the role that handles the translation of signaling and possibly encryption between your internal Link Server 2013 environment and your PSTN gateway or your SIP trunk connection. The mediation server is typically configured to listen on a secure port using TLS. To define the port that your mediation server is going to listen on, you define these settings inside of your topology builder. Any of the qualified gateways in the Open Interoperability program will support TLS, but they can also be enabled for TCP-based connectivity also. When you're coexisting with a PBX like we have at Carve Rock Fitness, the mediation server will also handle calls going or coming from the PBX. Now with an IP-based PBX we can use direct SIP. With our PBX we're going to have to put in a gateway, because we have a legacy PBX that doesn't support direct SIP. So my mediation server will communicate with the PSTN gateway, and the PSTN gateway will communicate over with the PBX. When you define your mediation server role inside of the topology builder, the mediation server role can be co-located on your front-end servers. They can also be dedicated. When you're using dedicated mediation servers, they're a lot more scalable. They can handle a lot more concurrent calls. You also have to consider the costing when you're setting up SIP trunk connections from the session border controller of your provider over to your mediation servers. If I have a lot more mediation servers, it could mean a lot more cost. What are the main functions of a mediation server? Well, the mediation server translates SIP over TCP. So if you have a gateway that doesn't support TLS, it handles the encryption and decryption of secure real-time transport protocol traffic. And in the case of a SIP trunk connection, the mediation server also provides a connection to the session border controller of your ITSP, in a lot of cases eliminating the need to have a gateway. Let's take a look at a demonstration. In this demonstration, we're going to see how to configure the mediation server and your gateways inside of the topology builder. In this demonstration, we're going to see how to define the settings for your mediation server and your gateway objects inside of the topology builder. We'll start by opening up our Link Server Topology Builder. We're going to download our topology from the existing deployment. Next, we'll define the name for our topology file. And now we're inside of our topology builder. So let's open up our directory tree. You can see that I have two sites, one called Scottsdale and another called Phoenix. Now Phoenix isn't set up yet, but I have defined the settings inside of the topology builder. In my site called Scottsdale, I'm going to navigate down to my Link Server 2013 Enterprise Edition front-end pools, and you can see that I have my pool called pool.carverockfitness.com. We'll edit the properties for the pool, and down below you can see that I've got Enterprise Voice currently enabled. We scroll down a little bit further. Next you can see that I can define my resiliency settings and my backup registrar pool. So if we define paired pool sets, here's where you can define the associated backup pool. So in my case, Scottsdale would use Phoenix and Phoenix would use Scottsdale. We can also define the automatic failover and fail back intervals for voice, and that's measured in seconds. We'll scroll down a little bit further. At the bottom of the console, you can see that I've got the mediation server co-located on my front-end server.
I'm also using a listening port of port 5067 for my secure TLS-based communication. You can also enable TCP port communication as well. At the bottom of the window, you can see that I've got a defined trunk. If you were looking at the topology builder in a Link 2010 based environment, instead of seeing trunks, you would see your gateway objects. With Link Server 2013, Microsoft has added this trunk configuration to the product. The trunk configuration configures the ports that you're using, and it links the mediation server over to the gateways. We'll see an example of a trunk configuration in just a moment. Let's click on Cancel.
A little further down, you can see that I have my mediation pools. You'll notice the name of my mediation pool, pool.carverockfitness.com.
Well, that's my same front-end pool. It's co-located. So here you see I have the same settings. We're going to click on Cancel. Next, we'll look at our shared components. And inside of here, you can see that I have PSTN gateways, and I also have my trunk configurations. If I want to create a new PSTN gateway, I would click on New. So I right-click, go to New IP PSTN Gateway, and then you give your gateway a name. And we're going to use TLS, so we'll put TLS on there for a label. We click on Next. Then you define the IP addresses that you're going to be using for communicating over with the gateway. Do I want to use all configured IP addresses, or do I want to limit service usage to selected IP addresses? In the property sheet, we can also configure the system to use IP version 6 instead of IP version 4. We'll click on Next. Then we define the root trunk. We give the trunk a name. We define the listening port for the gateway, the SIP transport protocol, whether it's going to be TLS or TCP. We define the associated mediation server and the mediation server port. So the trunk draws this correlation between the mediation server and the gateway and the ports that's used to communicate and the transport protocol. So it kind of ties it all in together. We'll click on Finish. Down below you see that I have my trunks, and if you want to edit the properties for a trunk, you can do that directly. We'll cancel on that. I'm going to open up my branch site called Mesa. And here I've got Link Server 2013. And I've got my Mesa SBA. If I right click and I go to Edit Properties, now whether this is an SBA or an SBS, it doesn't matter, in the sense that when you go in here, you're going to see the same properties. We're going to scroll down to the bottom of the property sheet. And you'll notice that I have my mediation server and it is co-located. When you set up an SBS, or if you purchase an SBA, the mediation server role is part of the deal. And what I mean by that is that when you set up a survivable branch server, the SBS is only going to have the mediation server and the registrar role installed. If you purchase an SBA from a vendor, the SBA will come pre-shipped with Microsoft Link pre-installed on it.
And the survivable branch appliance will have the mediation server role, the registrar role, and an integrated gateway built right in.
Let's scroll back up a little bit. And you can see that I have my resiliency settings. I've got the associated user service and backup registrar pool, pool.carverockfitness.com. When you set up a Link 2013 branch site,
a Link 2013 branch site has to be associated with the central site because that's where it goes to gain access to the user mode application services.
For example, if I'm a client out at the Mesa site and I'm registering with the Mesa SBS, the survivable branch server, when a client connects over to the survivable branch server or to an SBA for that matter, the SBA or the SBS does not run application services locally. They get them from the central site that they're associated with. So if I'm a client out in Mesa, when I go to schedule a conference, that's not going to run on the Mesa SBS. That's going to run on the central site. In my case here, it's Scottsdale. We'll click on Close. Now when you're done making the changes to the console, you would typically publish your topology, right-click, I'll go to Publish Topology, and then I'll click on Next. What you typically want to see is a bunch of successful verifications that your topology was published successfully. Now in my case, I have a couple of servers that haven't been installed and they're not up and running, so I should see a couple of errors. Now, if I wanted to take a look at what was going on, I could click on View Logs.
As you can see, my system ran the publishing with errors, and that's because my pool 2 is not actually up and running right now. My servers aren't installed yet. That's coming shortly. But as I look through the logs, you'll be able to see the errors.
And you can see my site Phoenix is having some issues. Let's close out of there. In this demonstration, you've seen how to go into the topology builder. We've seen a lot of the settings for setting up the mediation server, your gateways, and also the trunk configurations. Don't worry about the trunks. We're going to talk about those in more depth when we look at how to configure enterprise voice. We still have to see how to set up things like dial plans, voice policies, PSTN usage records, routes, and trunk configuration. Before you go into the topology builder and you start defining your gateways, there's usually a lot of planning involved before we get to this point. The process of going in and defining your gateways should be the easy part. It's the planning where you spend the majority of your time. Well, I hope you've enjoyed the demonstration, and we'll see you in the next video.